All right, good evening. Appreciate everyone sticking it out this long. I know 6 o'clock's a little late for a talk, so I'll try to be quick. Hit all the important stuff. The project has been released on GitHub, so after the project, if you want to go and grab it, feel free to. I've also got a giveaway here, so let me forget about that. So yeah, pretty excited about this. About me, I'm an Army veteran. I spent about 12 years in Army Special Operations. Upon getting out, I decided what was I going to do with my life. I kind of somehow magically stumbled on the offensive security website and signed up for the OSCP. Had no clue what I was getting myself into and never looked at a Linux terminal before. So it was either get the certification and move into penetration testing or re-enlist again and stay in a little bit longer. So luckily I passed certification, got out. Been doing penetration testing now for, I want to say about 9 years. Currently, I'm a practice director at Optiv Security on the attack and penetration team. Started out at Fishnet Security and kind of worked my way up from consultant to director. Absolutely incredible company. I can't say enough good things about it. My passion in security is physical security. Anyone that knows me knows that I can talk about physical security all day, every day, and never get old. I am not a developer, although I did develop this tool. When you go and look at it, if you are a developer, give me a little leeway. It does work, and that's what matters to me. And one of the things I'm most proud about is got a little feature in the prompt comic book. Thanks to Ralph, some of our shenanigans from doing previous physical engagements warranted itself a little post in there. So I'm very excited about that. So shout out to Ralph and the Black Hills guys. On the agenda, first we'll talk about why Doppelganger kind of came about, what the goals were, features. We'll go over the hardware, some of the code, how it functions, why it functions, do a bit of a demo. Only thing we're not really going to go into is Wiegotcha basics or the RFID technologies or cloning tactics. There's been a ton of great presentations on that in the past, and I'll have some references to those at the end of this deck where I can go in and really dive into the technical nuances. This is more so about the tool itself and how it's intended to benefit physical security practitioners. So why? Our team has a number of physical security kits that we pass out to our consultants so they can go across the country, do physical break-ins, badge cloning, you name it. And over time, those kits have got a little bit weathered, been thrown around by TSA, what have you. We previously used Wiegotcha. I'm sure how many people do physical security systems? Outstanding. So everyone's probably familiar with Wiegotcha on the long range readers. So we were using that for a number of years. We had a kit go down. We had to get it up relatively quickly to meet our requirement for our line of business. So I went online to search for RaspberryPi Zeros in December of last year and was astounded by both the lead time to get one and the cost. Typically, they've been about $15 in the past and would show up at your door the next day. With the Raspberry Pi shortage, that is no longer the case. As you can see, some of them shooting up to almost $170 just for the Raspberry Pi. So cost and availability wasn't there. And also, I had lost some tech skills over the years as I've kind of moved out of the consultancy and into practice leadership and doing more of the business stuff. So I wanted to kind of rehone my focus, get back into doing something technical. And I think this project, being physical related, really aligned with that. So with that, everything that I did for this project was directly geared towards making life easier, faster, better for physical security practitioners that are carrying these long-range readers around, operating them day in and day out. So number one, the goal was to reduce the amount of soldering and wiring that goes into getting these things operational. Everything needed to be Hotswappable with readily available commercially available products. You'd be able to go onto Amazon and overnight an ESP-32 to yourself in a hotel room to get your reader back up if you need to. The operator can't go into a comms black hole. So again, Wiegotcha is an absolutely incredible tool. Only downside we had as a team, so we connect to that. Our wireless was tied up to that device, which had no internet connectivity. So if somebody's in the car watching our back, they can't really send us a text because we're in a comms black hole. So number one, most important thing is we need to be operational at all times on communications. Another nice to have that I wanted to do was to be able to have egress notifications. So you should be able to put your phone in your pocket, have your long range reader on your side, walk around, get your badge read without bumbling around with your phone, wondering if it's a good read, if it's a bad read, if you got to read it all. You should just get a notification either to someone out in the car, to your email, to your text, whatever it is, letting you know that you have a valid read. Other than that, error handling, that's a big one. A lot of times you go and get a read, you look down and you just see a bunch of zeros across the screen, and you didn't actually get a read. Maybe you're going too fast past someone, or maybe there's some EMI that prevented that badge from actually catching. So instead of flooding your log, put some error handling in there to make sure that those bad reads don't get logged. Only thing that's going to come through that web interface or into your notifications is a good solid read. Also, easy configuration and reset. So as I mentioned, our team uses these kits. They go from consultant to consultant on different engagements. So at the end of the engagement, we're going to be able to just push one button, wipe the device back to factory defaults. The next guy to use, we're not sending compromised card data through TSA. Yeah. Features. So we use a wireless configuration manager to set everything up. Pretty straightforward. We got MDNS running, so that way instead of having to type in an IP address or guess the IP address of your device, you just put in the name, go right to it. Optional. You can do the text or email notifications. You don't have to. It's got a clean web interface for sorting, downloading the card data, as well as resetting the device itself. So the device I chose to go with was from SparkFun. Absolutely incredible company, great technical support. Again, I'm not a developer, so I just kind of bought these devices on a whim, hoping that they would work. Primary reason why I chose the IoT Red board first is it had a number of different power options as I was developing things. I wasn't sure how I wanted to power the device, and it also had a SD card slot. SD card slot essentially just hosts the web application as well as stores the cards that you capture. So in the event that something does happen, your board gets fried, that card data is still on an SD card, you can pull it out and keep your engagement moving along. The Thing Plus USB-C board, I grabbed that one after I kind of dialed everything in. That's just a smaller form factor. Either one will work with the code. You just have to make slight modifications depending on which device you intend to use. You can use any ESP-32, assuming that it has an SD card slot. You just have to go in and modify a few of the dependencies to make it work for your particular application. These are just the devices I chose. I have tested these in the MaxiProx, the SE-R90. I put the specific model number up there, as that one has legacy support enabled, so it allows you to clone not just SE badges, but legacy high-class badges as well. I've also tested the Indala reader. Just a few things that you'd want to grab if you are going to build one of these readers in addition to the ESP-32 or whatever RFID reader you're using. These are just some components that I've come to accept as the best possible solution for our team. Wiring, so we do have to use a logic level converter when setting up the device. Reason for this is the RFID readers are putting out a 5-volt signal. The ESP-32s, they say they're not 5-volt tolerant, although I have wired them directly to it, and it's worked. Really what you should be doing is stepping it down to 3.3 volts. That logical level converter allows you to do that. The way that's working is you're receiving the data 0 and data 1 input from the Wiegotcha side. It's receiving that at 5 volts. There's an HV pin that goes to a 5-volt connector on the ESP-32. That's just letting the logic level converter know what's 5 volts. And then it's also got a LV side, which connects to the 3.3 volt side, which allows the device to convert it appropriately. So wiring instructions for the SC-R90. All this stuff will be up on the GitHub as well, if you want to go and build it yourself. For the Maxi Procs. And then finally, the Indala. Indala, you're going to need to use the Thing Plus C board, as you'll see here in the next photo. It's much tighter space to work with, but it fits nicely. Here's the device installed inside the Indala reader. Again, super simple. You can either solder header pins on, solder the wires directly to the board. I like to use the screw terminals. So that way if the device does go down, just undo the screws, pull it out, put a new one in, you're ready to go again. Here's the install on a SE reader. Again, super simple, nothing to it. The code. So it's written in C++ for the most part. The web application is HTML and some JavaScript to do some specific functions. But if you were to grab the GitHub repo today and you have an ESP-32 device, be it the IoT repo or the Thing Plus C, you just go in and uncomment or comment depending on what device you're using. Just don't change anything below the line that says don't change anything. Those are all the dependencies that the firmware relies on. Within the code itself, you can do a number of things to suit your own needs. For the IoT Redboard and the Thing Plus C, right there in the comments, it tells you which pins to enable, depending on what device you're using. Again, you can use any board. You'll just have to go in there and modify this to suit that board's need. Some user configurable stuff is right there. You change the SSID, the password, whatever you want it to be. I would recommend if you're setting up multiple kits or if you have multiple readers, like we send out 3 different readers, don't set the SSID all to Doppelganger. Change it a little bit to like Doppelganger Maxi Procs, Doppelganger SE or whatever suits your needs. That way you're firing multiples up at the same time. You're not getting confused as to which one you're actually configuring. Other things that are important to configure to your needs would be the portal timeout. So when you fire this thing up, it's going to go into a configuration portal, which is essentially just a captive portal. So that way you can go in and find the hotspot or cellular device you want it to connect to. It'll sit there for 120 seconds. If no one connects, it'll just reboot. If you save a device, say you save your phone and you're always using the same device, it'll automatically look for it and connect. If for whatever reason you send this on to somebody else, you can't clear it, after 30 seconds of it being powered on, it will fall back to that configuration mode, so that way you can go back in and it will just host the Doppelganger network, so that way you can configure your device. Boot process. So a bit about the boot process. So what it does initially, it fires up the GPIO. So it tells the ESP-32 where to be looking for card data. It initializes the little FS file system. Only thing that's stored on that file system is the configuration settings. So if you submit your email credentials in there, we don't want that to go to the SD card. We want that to go on the device itself where it's protected at rest. So that's the one thing that's stored there. Other than that, you really don't need the little FS on there. Then it'll attempt to connect to any stored networks that you have. If it's not available, again, it'll enable that configuration mode. And then it'll try to load the stored notification preferences. Again, this is your email account and where you want the card data to go to. Then turns on the MDNS and then gives you the connection information. Again, this is all under the hood stuff. You're not going to see this if you're just operating day to day, but if something does go wrong, you can plug it in, easily see where things are failing. Then it initiates the SD card, starts the web server and the WebSocket service. WebSocket service is only there for the device resets and the configuration stuff. So you're just sending simple JSON back to the device and it's performing actions for you. And then it initializes the NTP server, which will be required for your notifications. And then it tells you whether or not your notifications are enabled or disabled. This just talks again a little more in depth about what's going on with the configuration timeout. So initially it's going to try to connect to your device. It doesn't see it. It's going to time out, go into that configuration mode so that way you can log in and set up a new device or reset it entirely. And then after 2 minutes, it's automatically going to reboot. For the card handling, anytime you get a bad read, it'll dump out the output of that read. It's just a little note there that kind of tells you some of the things that could cause that bad read. Either you're walking too fast past your target, or maybe there's a loose connection inside the reader, or maybe there's electromagnetic interference with the reader itself. It will dump the data right here to the back end of it. So if you're connected to it directly, you'll be able to see what it's dumping out. Otherwise, it's not going to go to the log. We don't want to flood the user interface with bad reads. The cards.json file stores everything that the web application is viewing. So the only thing that goes there is the bit length of the card, the facility code, and the card number. Other than that, we don't care about all the raw data when you're walking around forming these bad reads. You'll want to look at that afterwards, which all that's stored in the cards.csv file. All that raw data is stashed in there, but while you're operational, you don't need to be flooded with a bunch of useless information at the time. And then again, if you have notifications enabled, it'll spit out that data to your mobile device, wherever you want it to go. Here's a look at the Wi-Fi manager. So initially, when you turn it on, it'll pop up all the networks. The way I have this tuned right now is anything below 25% doesn't show up here. The reason why I do that is if you're in a crowded city or maybe you're in a hotel like this one, you're just getting flooded with networks and this list becomes a little cumbersome. So throttling that out, you just get the device that's right next to it, maybe some others. You can adjust this within the code itself to a different percentage, but right now it's set at 25%. Here's a quick look at the web interface. I'll do a demo. But wanted to show this here. The only thing that we can't demo here with this setup is the actual notifications, but essentially that's what it looks like. You just get a text message that would come through, or you can send it to your email. I kind of prefer doing it to email, but it's completely up to you. On the GitHub page, it'll show you how to tie different cell phone carriers into it, so we can send an email to text. All right, demo. We'll see if this works. All right, so here it is. It's in configuration mode. One thing I'm not going to be able to show you is configuring it to this network here. Just give me just a moment. So here I am connecting to it.
Is it the wrong screen, Travis?
Oh, is it not?
It's on the demo.
Yeah. Let me see if I can stop sharing and reshare. One second, let me get this connected.
It looks like it may have dropped.
Sorry.
Should I take in the power or the PowerPoint out full screen?
Yes, that works.
Yep.
Is it still sharing?
Yep.
Okay. All right. All right, we're gonna hope that it's connected here.
I don't think Zoom is sharing, it's just got the camera on.
Gotcha, okay. All right, so it's connected now. There we go. So here's the device. This is what you'll see on your mobile phone. Fortunately, I can't just share this to it, so I kind of set up a demo here. If you were to go in and clone a badge with a bad read, see if we can make that come up. There's some bad reads there. It's not coming to the web GUI. Good reads, they're going to come through, no issue. I do not have it set currently to auto refresh when a badge comes in. That's one thing that we found to be a little cumbersome. When you're sitting there watching it, it's constantly refreshing on you. So if you hit the reload, you're going to get that new badge every time. Within the notification settings, this is where you set everything up. Just hit enable, put your SMTP information in there, username, password, recipient. Just hit update preferences, and that'll go through. It'll automatically start sending new tags that you send in through there. Whatever reason, my access point is backed up. Should be back. So if you turn off your device for whatever reason, it'll automatically connect back to it when it sees it again. For the reset function, everything's in here. If you want to erase the card data, it's essentially just sending a JSON request back. Letting you know what it's doing. So it's wiping the cards. You should be able to go back. Cards are gone. A new card. You can do everything. You can clear just the wireless credentials, just the notification settings, or you can do a full device reset. Full device reset dumps everything all at once. That's essentially it. One thing I didn't show you was the CSV file. It's just like the Wiegotcha CSV file. Includes all the raw data, the hex. It's all in there. That is essentially it. So future development. So I currently have another device that I've been working on the past month and a half or so, which is the next iteration of this. Is essentially just an LTE variant of this. It has no Wi-Fi whatsoever. So it uses a multi-class reader, so you can do with multi-class, you can do different plugins into that. You can do Prox, DALA, SE, Bluetooth, you name it. That reader ESP-32 just sits on the back end of that. And as soon as it gets a read, it'll send it out over LTE. So direct text, no email, no Wi-Fi signature. So you can, I call it a slap device. You just slap it on the side of the building next to an existing reader. Has less of a signature without the wireless network broadcasting. So excited for that. Should have that ready to go by Q4 of this year. Yeah, so that's essentially it. Credit and shout outs. None of this would be possible if it wasn't for Fran Brown and Dan Smith doing the initial research to get the Tastic RF or Tastic Thief, whatever that thing's called. Tastic RFID Thief up and running many years ago. That's kept us in business doing physicals for so long. And then also Student Bacon. Try to reach out to this person on GitHub. They did a Wiegotcha refresh of the original Tastic code, and without that repository, this project certainly would not have happened. So yeah, shout out to those. That is it. To get the code, it's on Optiv's GitHub / Doppelganger. Grab it. You let me know if it sucks or not. I'll take any feedback, good or bad. I am not on the socials, but I am I guess I'm on LinkedIn. So if you want to reach out to me, probably LinkedIn's probably the best place to do it. Any questions? Yes, sir.
Have you looked into the ESP protocol at all for exfilling the card data?
I have not, no.
There's like a thing that Expressive made for the ESP chips. And it's like a protocol that sits on top of 802.11.
Mhm.
But they claim they can get something like 700 feet of line of sight distance, like data across, but you won't see it with a traditional like Wi-Fi tool.
Huh.
So you could kind of exfil it without there being the possibility of someone seeing that you're sending like Wi-Fi data out, unless they have like, you know,
Would it,
a crazy.
are you referring to, what's that? LoRaWAN, yeah, you're referring to LoRaWAN?
No, it's like their own thing that it's their own protocol that they built specifically for the ESP chips, and it sits like it's still using 2.4 gigahertz, but it's like I think it does something like I think it uses certain packets to like send information that you would traditionally use to just do like, you know, maintenance on a 802.11 network. I'm not 100% sure how they do it. But they also, I guess now they added support for a long range mode too. So like you can get like up to a kilometer with that. I haven't played with either of those, so I don't know if I believe their numbers. But it might be something worth looking into if you want to be a little more like sneaky with getting the data out.
Definitely look into it. Anything else? Outstanding. All right, so I have everything but the reader. That was just too expensive to give away. I'm not sure how we want to do this. Arm wrestle is good. I guess I would say anyone that's actively doing physical security assessments, I would say guess a number between 1 and 10. Whoever gets closest to it.
Raising hands.
Raising hands, yeah. All right.
6.
Got it. All right. Thank you all. Appreciate it.